To simplify, the first thing we're going to do is get rid of our parentheses. So I'm going to distribute the 4 to both parts. So in my denominator, I'm going to have x, and when I distribute, when it's a parentheses, raised to a power, I say pow, multiply now. So I'm going to multiply. 7 times 4 is 28. 3 times 4 is 12. So that's my first step. Now I don't have any parentheses. Second step, if I change the line, or if I cross the line, I change the sign. So what that means is, if anything's negative, it moves. This first term is not negative, so it stays. This term is negative, so it moves to the bottom. It becomes positive. That's positive, that positive, so it stays. All right, we're getting closer. So what we have to determine is, let's start with the y's. They're both on the bottom. So when they're both on the same spot, either both top, both bottom, we just add them together. And therefore, I get y to the 14th. The next question I have to ask myself, are there more x's on top or on the bottom? Well, there's 8 on the top and 20 on the bottom. So there's more on the bottom. So I'm going to leave the x's on the bottom, and I'm going to move the ones on the top by doing the opposite. So 20 minus 8 is 12. Now, I can't just leave blank on the top, therefore I'm going to put a placeholder. And there's my final answer for number 5. What I would like you to do is try the same thing. It's a very similar problem on your own page. All right, we're going to simplify both pieces here to see if we can add them together. I'm going to start with the 6. If I break down 6, 2 goes into it 3 times, 3 goes into it 1 time, and I know I can stop when I have a 1 on the top. And I don't have pairs of anything, so I have to leave it. So let's try 24. 24 is even, so 2 goes into it 12 times, 2 goes into that 6 times, 2 goes into that 3 goes into that 1 time. So I have a pair of 2's, and a pair of 2's will come to the outside. So I have -4, I have that pair of 2's, and left over I have a 2 times a 3. So let me go ahead and simplify that a little bit. 4 times 2 is 8, 2 times 3 is 6. Now, since the 6's are the same, I leave the label, and then I add and subtract the numbers in the front. So 12 minus 8 is 4, and my final answer is 4 rad 6. Now, suppose I had something like 2 rad 6 minus 4 rad 3. If I simplified it down as far as I can, and that was my final answer, then I would leave it because what's inside the radical is not the same. So I cannot combine them into one. You try a problem that looks like this. Expand. When I have to expand something, the first thing I'm going to do is I'm going to rewrite it because there's 2 of them. So I'm going to write it as 2x minus 5 times 2x minus 5. Now, I personally like the box method. If you like the method where you draw arrows, then please draw arrows. The box method, 2x minus 5, that goes on the top, that goes on the side, 2x minus 5. Now I'm going to take 2x, multiply it by 2x. 2 times 2 is 4, and I have a total of 2 x's. 2 times -5 is -10 with an x. 2 times -5 is -10 with an x. And -5 times -5 is a positive 25. So the reason why I like the box method, more often than not, my like terms are diagonal. So I have 4x squared minus 20x plus 25 as my final answer. You try a problem like this. All right, because both parentheses are touching, this means multiplication. So I'm going to draw my boxes. I'm not sure why I made them so big this time, but I did. I have 5t squared, a positive 6t, negative 2t squared, and a positive 3. So I'm going to do the same thing. Negative 2 times 5 is negative 10. And I have a total of 4 t's because I have 1, 2 there and 3, 4 there. Negative 2 times 6 is negative 12. I have 2 t's there and 1 t there, so I have a total of 3. 3 times 5 is a positive 15, and I have a total of 2 t's. 3 times 6 is a positive 18, and t. Notice that in each box, there's a different amount of t's, so I'm just going to put them in order. Negative 10, t to the fourth, minus 12, t to the third, plus 15t squared, plus 18t is my final answer. You try one that looks like this. Next problem. Notice how the parentheses are not touching and there's an operation in between. So what I'm going to do is I'm going to distribute this negative to all three pieces. So that will give me negative 2x. Negative times a negative is a positive 10x. Negative times a positive is 5. So really it just changes the sign of everything. There's nothing in the front here. So I'm going to bring everything down and take it out of the parentheses. All right, so let's start. I have an 8x squared. That's the only one, so I've used it. Next, I have an x term, an x term, and an x term. So I'm going to take 42 minus 2 plus 10, and I get positive 50 with the label of an x. Last, I have 20 minus 5, which is a positive 15, for my final answer. You try a problem like this. Find the product. We've done one similar, but this time I have a trinomial. So I'm going to make this one a little bit bigger because I know I need 3 by 2. So I'm going to put the 3 on the top, 5x squared plus 6x minus 1, and the 5x minus 6 on the side. So now I'm going to multiply. 5 times 5 is 25, and I have a total of 3 x's. 2 there and 1 there. 5 times 6 is a positive 30, and a total of 2 x's. 5 times negative 1 is a negative 5 with an x. On the bottom, 5 times 6, negative 6 is negative 30 with a total of 2 x's. Negative 6 times positive 6 is negative 36 with an x. Negative times a negative is a positive 6. So last, my diagonals are my like terms. 25x to the third, those cancel. So if I had to put in a value, it would be plus 0x squared. The next two right here, they're the same sign, so minus 41x plus 6 is my final answer. You try one like this. Factor. I like to factor because it's kind of like a puzzle. So we're going to look at the end term, and it needs to multiply to give me this term. So I'm going to write my multiples of 15. 1 times 15, 2 doesn't go into it, 3 times 5, 4 doesn't go into it, and I'm back to 5. So these are the two choices I have. Well, it needs to subtract to give me -2. So the only choice I have is this. When I subtract those, I get 2. When I subtract those, I get 14. Now, whatever this sign is right here is the bigger number. So that's going to get that sign, and that's going to get a plus. So subtraction, they have opposite signs. Addition, they will have the same signs. But you can just play with it until you figure out, how am I going to get a -2? So my answer is x plus 3 times x minus 5. It doesn't matter which order you write it. If you write x minus 5 times x plus 3, that's also correct. You try one. Remember, this has to multiply, but this time it's going to add to give you a positive 11. All right, this one's a little bit different because I have a leading coefficient. So the first thing I have to do is multiply 5 times 5, which is 25. So now I need multiples of this, 1 and 25, 5 times 5, and those are my only two choices, that subtract to give me 24. Well, this subtracts to give me 24, and this subtracts to give me 0. So these are my choices. Now, if it needs to be a positive 24, that needs to be bigger than the smaller number. Since there's a leading coefficient, we've got to factor by grouping. So I'm going to change this 24 into minus 1x and plus 25x, because when I add those together, it gives me 24, and bring everything else down. Next step, I'm going to group the first two and group the second two. So I'm going to factor. Is there anything I can take out of the first two numbers? And the answer is no, so I'm just going to take out a 1 so you can see. If I divide a 1 out, I'm left with, oops, excuse me, there is something we can take out. Let's erase that. I can take out an x. When I divide an x out of both, I'm left with 5x minus 1. Next, I'm going to take out a positive 5. Whatever this sign is, I'm going to take that out. When I divide 5 out here, I'm left with 5x minus 1. Now, what do I have in common between this and this? In common, I have a 5x minus 1. Left over, I have an x plus 5. And there's how I factor with a leading coefficient. You try this one. Factoring two perfect squares. Remember, perfect squares are 2 times 2, so the perfect square of 4 is 2. 3 times 3 is 9, so the perfect square of 9 is 3. 4 times 4 is 16, so the perfect square is 4. 5 times 5 is 25, so the perfect square is 5. 6 times 6 is 36, so the perfect square is 6, and you can continue that pattern. So when you see two terms and they're both perfect squares, we're going to factor them like this. The square root of 4 is 2, so each one gets a 2, because 2 times 2 is 4. I'll put an x in each for a total of 2 x's. The square root of 25 is 5, and here's how we finish. 1 plus, 1 minus. You try a problem like this. You might have to extend your list so you can figure out what the square root of 121 and 144 is. Or if you have a calculator, your calculator can do it for you as well. Factor. So again, here's one with a leading coefficient. So I have to take 4 times 25, which is 100. Factors of 100. 1 and 100. Remember, they're going to have to add to give me 10. That adds to give me 101. 2 times 50. That adds to give me 52. That's not going to work. 4 times 25, that's going to give me 29. 5 times 20, that's going to give me 25. 6 doesn't, 7 doesn't, 8 doesn't go in, 9 doesn't go in, 10 goes in 10 times. And that adds to give me 20. And looking at this problem, it doesn't factor, so I'm going to go back and give everybody points for number 19. All right, simplify. Simplifying means we're going to factor the top and we're going to factor the bottom. So factoring the top, multiples of 25. 1 and 25, 2 doesn't, 3 doesn't, 4 doesn't, 5 times 5 will add to give me 10 if they're both plus. So I have an x plus 5 and an x plus 5 on the top. These two things mean the exact same thing, they're just written differently. Factors of 35. 1 and 35, 3, 4, 5 and 7. 5 and 7 add to give me 12 if they're both plus. So I have an x plus 5 and an x plus 7. Now, all I'm going to do is, like factors, I'm going to cancel top and bottom, so I can cancel one of those with one of those, and my final answer is x plus 5 over x plus 7. You try one. Let me give you a hint. The difference of two perfect squares. So you're going to have the exact same bubbles, 1 plus, 1 minus. All right. Dividing fractions is as easy as pi. Flip the second and multiply. So the first thing I'm going to do is flip the second, and then I'm going to multiply these. When I mean multiplying, it means I'm going to factor them. Multiples of 6, 6. 1 and 6, 2 and 3, that subtract to give me a negative 1. So my factors will be x minus 3, x plus 2 on the top. Multiples of 15. 1 and 15, 3 and 5, that subtract to give me 2. X plus 5, x minus 3 gives me a positive 2. Multiples of 10. 1 and 10, 2 and 5, that add to give me 7. X plus 2, x plus 5. Multiples of 6, that add to give me 5, which would be x plus 2 and x plus 3. And I got it from here. All right. Now, I can cancel anything on the top with anything on the bottom. So I have an x plus 2 and an x plus 2, an x plus 5 and an x plus 5. X minus 3, x minus 3. The only thing left on the top is an x plus 2. The only thing left on the bottom is an x plus 3. And that's my final answer. You try one. Last problem here. We're going to subtract these two, and I need a least common multiple. So I'm going to factor this. Difference of two perfect squares, x plus 4, x minus 4. So I'm going to cross that off and use the factored version. This one, I can factor out a 3, and I'm left with an x minus 4. So my least common multiple is I need an x plus 4, an x minus 4, a 3, and I already have an x minus 4. So the next piece we're going to do, what am I missing in these two terms? If I have these two pieces, I'm missing a 3. So let's put a parenthesis and say I'm missing a 3 top and bottom. If I have on the second one a 3 and an x minus 4, then I'm missing an x plus 4 top and bottom. So let's rewrite this. On the top, I have a 3, an x minus 3, minus 4, an x plus 4, all over my least common multiple of 3, x minus 4, x plus 4. Now, biggest mistake here, do not start canceling because I have to simplify this before I can cancel top to bottom. So let's distribute. I have 3x minus 9 minus 4x minus 16 all over my least common multiple. So my last step here is combine like terms. 3 minus 4 is negative 1x. Negative 9 and a negative 16 would be a negative 25 all over the least common multiple of 3, x plus 4, x minus 4. Problem I would like you to try. So please email me your problems that you did on your own sheet of paper with your work as neat as possible, and I'll go back and give you some points for the ones you got correct.